Good day. Today's lesson is brought to you by the Guinness Brewery Company, makers of fine, dark stouts for well over a century. So we'll get to why that is later on, but first we'll start our lesson. So we already have covered finding confidence intervals based on the normal distribution, and we looked last day at the distributions at confidence intervals for population proportion. Today we're going to look at population means. Now, based on what we've done before, we could use the normal distribution, and so that the confidence interval is based on the statistic plus or minus the critical value, Z star, times the standard deviation of the statistic. And so the standard deviation of the statistic is this time sigma, which is the standard deviation of the population, divided by the square root of n. And that's the critical value. Now, the problem with this is that when we don't know what our standard deviation of the population is, we would have to estimate using S subscript x, which is the standard deviation of our sample. Now that is, of course, introduces a new variable. We have the variable of the actual sample mean, and then we would have the sample standard deviation. So we're adding more variability, and which is not too bad if you've got large samples, very, very large sample sizes, but for smaller sample sizes it does cause a bit of trouble. And so this is why, here's the story behind why the Guinness Brewery Company is responsible for what we're covering today. So William Seeley Gossett, and here's a picture of him from Wikipedia. He was he studied chemistry and mathematics, and he got a job working for the Guinness Company in Ireland, and he was one of the people in charge of quality control. Now, many people would envy him that job, being allowed to sample, because of course taste would have been part of the job. However, you might appreciate that he wouldn't want to have too many samples of his product that he's testing, for a number of reasons, including that it would be very costly to take too many samples. So he was trying to use small sample sizes, and he found that with those small sample sizes, the normal distribution did not tend to fit very well. And so he developed what he called t-distribution, which we'll get to in a few minutes. And he found that this would be very useful in many other applications other than in the brewery, and he was also working with the agricultural branch of the Guinness Company as well. So he wanted to publish his findings. Now, the Guinness Company had had troubles with previous employees publishing and giving away trade secrets, so they had a ban on that. But Gossett managed to convince the Guinness Company that his findings were very important and did not give away any trade secrets. So they agreed on the condition that he use a pseudonym, and his pseudonym that he chose was the name Student. And so the t-distributions are sometimes known as students' t-distributions. And so we will now use t-distributions for our confidence interval. And this is when we do not know the population standard deviation. Then we use the t-distributions. Once again, we're going to use the sample mean, and we're going to use, instead of the critical value, the t-value, and instead of sigma, we're going to use the standard deviation of the sample. So the t-distribution the statistic t, and this is kind of taking off of our formula for z, t minus of x bar minus the mean over s subscript x over the square root of n. It has a t-distribution with what we call n minus 1 degrees of freedom. So this statistic will have t to the n minus subscript n minus 1 as the sampling distribution of x bar is, sorry, as the sampling distribution of x bar is close to normal. So we're going to investigate the t-distribution a little bit more, and we'll see how the t-tables work that are in the back of your book, table B in your book. The t-distribution is bell-shaped, symmetrical, centered at 0, but it has larger areas in the tails than the normal distribution. The t-distribution will change depending on the sample size. And as the sample size increases, the degrees of freedom increases, and the shape of the t-distribution approaches the normal distribution. So here is a t-distribution for n equals 15. You can see it looks quite similar, but this area is a little bit bigger than that area. And in fact, that area in the normal distribution is 5%, and in the t-distribution is 7.4% for n equals 15. So this has 14 degrees of freedom, this one. What I would like you to do is to compare the normal and t-distributions on your calculator, and you're going to sketch the t-distribution with a number of different degrees of freedom comparing your graph. So over here you've got how you can plug it into your calculator, and each time you're going to, then after each one you'll change that number, which would be the degrees of freedom. So take a minute to do that.